Assalamualaikum and good day everyone. In this video, we will demonstrate the implementations of current hysteresis control of a BLDC motor. The main purpose of this demonstration is to show how the BLDC motor current can be controlled using a hysteresis current controller. This is the overall hardware setup used for the experiment. The BLDC motor is connected to the inverter driver circuit. The motor receives its supplies from the DC power source, while the switching signals are generated by the TI-DSP board. The oscilloscope is used to observe the switching signals and waveforms during operation. The computer is used to run the Simulink interface, where the motor can be started, stopped, and controlled by adjusting the reference current. This is the Simulink model developed for the BLDC motor hysteresis current control system. Based on the experiment requirement, the original simulations model were modified for hardware implementation. The EPWM blocks are used to generate switching signals for the MOSFETs. The GPIO blocks are used to read the Hall sensor signals, while the ADC blocks are used to measure the phase current from the current sensor. The measurement current is sent back to Simulink and displayed as an experimental waveform in real time. Next, the motor is active using the start and stop control in Simulink interface. When the enable button is turned on, the DSP starts reading the Hall sensor and current sensor feedback. The Hall sensor provides rotor positions information, which is required to determine the correct commutations sequence for the BLDC motor. At the same time, the reference currents can be adjusted using the control code in Simulink. This reference current becomes the target value of the hysteresis current control. The Hall sensor is used to detect the rotor positions of the BLDC motor. This feedback is important because the inverter must switch the correct motor phase according to the rotor position. The output signal from the current sensor is passed through a signal condition circuit before being connected to the ADC input of the DSP. The hysteresis current controller works by comparing the measured phase current with the reference current. When the actual current drops below the lower hysteresis band, the controller changes the switching state to increase the current. When the actual current rises above the upper hysteresis band, the controller changes the switching state again to reduce the current. This process happens repeatedly during motor operation. As a result, the phase current waveform raises and falls within the hysteresis band. This produces current ripple, but the current is still controlled around the reference value. On the oscilloscope, the switching behavior of the inverter can be observed. The switching signals are generated from the EWM output of the DSP and are used to control the MOSFET in the inverter circuit. If the hysteresis band is too small, the current ripple becomes lower, but the switching frequency becomes higher. This may increase switching losses and heating in the MOSFET. If the hysteresis is too large, the switching frequency will become lower, but the current ripple and torque ripple may increase. The waveform shown in Simulink represents the comparison between the reference current and the measured phase current. Based on the experimental waveform, the motor current is able to follow the reference current with some ripple. This ripple is expected because hysteresis current control uses an on-off switching method to keep the current within the hysteresis band. When the reference current is adjusted, the measured current also changes accordingly. This shows that the current sensor feedback, ADC reading, and controller responses are working properly. Overall, this demonstration shows that the hysteresis current controller has been successfully implemented on the BLDC motor. The system successfully combines the Simulink model's EPWM switching output, Hall sensor feedback, ADC current measurements, and inverter switching circuits to control the BLDC motor current. The motor operates stably, the experimental current waveform can be observed in real time, and the current response shows the expected characteristic of hysteresis current control. In conclusion, this implementation fulfills the assignment objective because the BLDC motor drive system is successfully controlled using a hardware-based current hysteresis controller, not only through simulations. That's all from us. Thank you. Assalamualaikum.